Well, hello everyone, and welcome to our webinar on best practices for securing your mobile apps. Today we're going to try and inform you about mobile security threats and really also help guide you with a series of tips, tricks, and best practices that you can quite literally implement today. Now we'll do this with a good balance of explaining the threats and how they apply to virtually every mobile development framework out there. We're also going to show specific tactical solutions to these threats. Now, mobile app security is something that can no longer be taken lightly. Virtually everyone is walking around with sensitive data, access to private corporate resources, and even protected health information in their pockets. So first, let's talk about some webinar logistics. Everything you see here today will be made available on YouTube in the coming days. This means if you have any audio or visual problems, rest assured you'll be able to watch this webinar in its entirety later on. We will be sending out follow-up emails in about a day or so with this information included. Now, what if you have questions during the webinar? Well, I see a few of you have already found the Q&A panel provided by GoToWebinar, which is great. This is here for you during the live portion of the webinar. Simply ask any question you want about app security or the technologies we show off today using that interface provided. We will do our best to answer as many questions as possible. Now, before we really begin today, I know these types of webinars draw in folks from all walks of life, and the solutions we cover today do not only speak to NativeScript, but also to virtually any other means of developing mobile apps. But if you are here and you're new to NativeScript, permit me 2 minutes of your time. Just so you know, NativeScript is a free and open source framework built and supported by Progress. Using NativeScript, you can build truly native mobile apps using JavaScript. And when I say truly native, I mean truly native. This isn't PhoneGap or Cordova or Ionic. These are real native apps built with JavaScript powering native UI. And if you're a web developer, well, you're doubly welcome here because NativeScript includes support for the Angular and Vue.js frameworks. And it also supports CSS for styling your apps and TypeScript. So when it comes to creating these native mobile apps with NativeScript, it really shines in some key areas. Performance. NativeScript apps, like I said, are truly native. When you add a button element to your app, for instance, the NativeScript framework automatically transforms that button into a native UI button on iOS and a native Android.widget button on Android, all without you having to write a single line of Swift, Objective-C, or Java. Now, apps written with NativeScript, like I said again, use JavaScript, TypeScript, Angular, or Vue.js. Apps are styled with CSS, and that is the same CSS you've been using for years, and the markup is a friendly XML syntax. Now, NativeScript also gives you access to the entire libraries of both iOS and Android device APIs without relying on plugins. Finally, you can also share code between existing web apps and your mobile NativeScript apps. In fact, you may already be using a NativeScript app today. The #1 app in the iOS App Store over the holidays was built with NativeScript. The Portable North Pole app was the most popular app over the holidays, and it's a shining example of how you can use NativeScript to create web and native mobile experiences with Angular from a single codebase. Pretty cool stuff. Now, if you'd like to see some more awesome sample apps, take a look at the NativeScript Marketplace. Here you'll find apps of all flavors and all types with openly copy and pastable code for you to use. There are some really gorgeous sample apps here, so I highly recommend you take a look. You can access these at market.nativescript.org. Now, I should mention that each sample app also runs in the NativeScript Playground. And what is the NativeScript Playground? Well, it's a 100% web-based resource that lets you dip your toes into the NativeScript waters without installing anything locally. You just need a web browser and a freely available app from the app stores called, appropriately enough, NativeScript Playground. The Playground also includes some engaging tutorials for Angular, JavaScript, and soon Vue.js. It's all available at play.nativescript.org. Now, community size is very important to us, and NativeScript adoption is really growing dramatically as well. You can see here how our download numbers on NPM have really exploded over the last year or so. Likewise, our adoption in the enterprise is expanding. Take a look here at just some of the companies we work with on a daily basis to create amazing mobile apps. Finally, if you want to stay in touch with us, the best ways to do that are via the NativeScript newsletter for a monthly-ish email on the hottest NativeScript topics. If you're on Slack, get your invite to the NativeScript community Slack at nativescript.org/Slack. And if you're looking for community support, check us out on Stack Overflow. And yes, Progress does offer paid support options as well. Okay, back to mobile app security. Now, as I mentioned previously, some of the technical implementations we're going to discuss pertain to NativeScript directly, but all the concepts apply to all mobile apps. And in fact, most of the solutions we present today, they have equivalents with other frameworks. But the first thing we need to learn is that no app is 100% secure, because there isn't one front door to be locked, right? Apps of all types have multiple layers and avenues that are potentially vulnerable to attack. So today we're going to look at these layers and provide a set of best practices for you that, while not a bulletproof solution, provide realistic and common sense protection. Let's look at those layers. Now today we're going to start with protecting our source code. We're going to look at how we can reduce code exposure, protect intellectual property, and avoid some basic and potentially very public mistakes. Next, we're going to talk about securing data on the device at rest. After that, we'll talk about protecting the integrity of our data as it moves back and forth between the device and backend. This isn't quite as simple as you may think. Finally, we're going to briefly talk about secure user authentication, really how you can use existing plugins and services out there to make identity management easier and, of course, more secure. All right, time to introduce our speakers. Today we have 4 different speakers covering different topics. First is me, Rob Lauer. I manage the Progress Mobility Developer Relations team. You can find me on Twitter at Rob Lauer. Next up is Pedro Fortuna, CTO and founder of JScrambler. You'll get a full rundown on what JScrambler provides in just a bit. Find Pedro on Twitter at Pedro Fortuna. Principal Developer Advocate TJ Van Tol is here as well. TJ works a lot with NativeScript and Kinvey, so he's going to provide some security considerations when we talk about using our backend systems. Find TJ on Twitter at TJ Van Tol. And last but not least, Alex Ziskind from nativescripting.com will have a brief cameo to talk about his new video course all about app security. Find Alex on Twitter at Digitalex. And while I have your attention, I'd be remiss if I didn't at least mention NativeScript Developer Day. It's coming up on April 11th and 12th in Amsterdam. We're going to have 1 day of workshops and 1 day of sessions focused on NativeScript development. I know I'll be there, and we have some other great speakers from Progress, Microsoft, and plenty more to be announced. We have early bird tickets available until the end of January. Go ahead and read more at nativescriptdevday.org. All right, so let's get started for real. And let's start with source code. Now, I hate to ruin your confidence in the app stores, but you should all know that apps shipped to your end users via the app stores or any other method are inherently unsecure. I mean this in the context that it is technically possible for a user to extract your source code from the app. You can try it out yourself today. Those IPA and APK files are really just effectively zip archives. Now, NativeScript, React Native, Ionic, it doesn't matter. None of these are compiled to native bytecode. JavaScript is interpreted on the device just like a browser. Now, if you're a traditional iOS or Android developer, I'm sorry to say you're basically in the same boat. There are plenty of decompiling tools out there that let folks read your code and potentially your secrets. So let's look at some strategies for securing your source code and keeping prying eyes off your goods, protecting your intellectual property, and really mitigating potential attacks to your apps and backend systems. Now, I'm certainly not trying to scare anybody here, as there are a lot of options we have to help lock down our apps. So let's start with minification and obfuscation of our code. Now, a popular obfuscation library is Uglify. This will take your perfectly legible code and mangle and minify it, making it effectively impossible to read by human eyes. So here, for example, is some random JavaScript code I pulled from the jQuery library. Now, you run it through Uglify and you get this. Now, it's not very legible, is it? It does provide a very rudimentary amount of protection at a very low cost. Now, the NativeScript CLI supports Uglify out of the box as part of its Webpack integration. Simply issue this command to create an Uglified build. TNS build Android or iOS with the bundle flag and the Uglify flag. Now, the problem here is there are plenty of beautification options out there that can take that minified code and make them readable yet again, which is what I just did here. So it's not exactly the same code, but it's pretty darn legible. So it was a good try anyway. Now, minification does have other benefits like parsing speed, but that's outside the scope of what we're talking about today. So why did I just mention a problem and a solution that may not really be that effective? Well, as you're going to see today, there are few solutions that are 100% foolproof. We're talking about adding layers of security, and this one maybe fools the most casual of hackers, if you will. Now, ProGuard is another option here for Android at least, but frankly, ProGuard will only hide native method calls in Java and won't help much for your JavaScript. But it's at this point that I'd like to bring on our first guest speaker. Let me introduce again Pedro Fortuna. He is founder and CTO of JScrambler. I'll let Pedro tell you how JScrambler can help solve those issues I just outlined for you. Pedro, take it away.
Thank you, Rob. It's really a pleasure to be joining you today. I think security in mobile applications has become a huge affair, and so today I will be focusing on client-side security. Let me just introduce myself. I am co-founder and CTO of JScrambler, a security company that is the leader in application shielding. So on client-side security, let's dwell into this. I'm fairly sure that almost everyone of you is working with JavaScript. As you know, JavaScript is everywhere, and this includes, of course, the mobile platform. Whether you love or hate JavaScript, it's still a great language to build complex applications that run on multiple devices, especially with the help of frameworks like NativeScript. So if you're developing a JavaScript application for mobile, this means that you are putting the core logic of your application and your business into the JavaScript code, which would be fine if JavaScript was stored securely on the server, but it actually runs on the client side. And because of this, JavaScript is in fact completely exposed to the end user and can easily be read and tampered with. So it goes without saying that probably you don't want the end user to go through your code and tamper with it, especially if it has something that is sensitive. But this is something that it happens and it keeps happening all the time. There are cases where attackers really all they want is to steal the code and to use it on their own, like probably to launch competitor applications. But there's also the motivation to tamper with the code to unlock some features or simply to avoid paying or to steal sensitive information. In either case, these attacks, they can hurt your business regardless of your business size. So this is why using solutions like JScrambler is important and can help you release your applications to the market with reduced risk. So JScrambler offers a number of different security layers. So the first one is advanced JavaScript obfuscation. You may already know what obfuscation is, but what it does is it rewrites the code of your application in such a way that it becomes really hard to understand what's going on. So let me show you an example on how that looks like. So as you can see, the original code is the left portion of the screen, and on the right you can see a transformed version of the same code. Extremely hard to read. We have a second security layer which we call code locks. So code locks is additional code, not originally present in the source code, which is instrumented into your application to enforce something about the way that the code is executed. For instance, you can lock the code to a certain operating system. You may want the code to run on Android, but not on iOS. So if the end user tries to run it outside the intended operating system, the code will detect this and will break on purpose to prevent the attack from being successful. We have a third layer of protection which we call self-defending code. So the self-defending is a combination of anti-tampering and anti-debugging. So if you change the code in any way, the integrity checks will be triggered and the code will break on purpose to prevent the attack from being successful. And the anti-debugger basically detects whenever someone is using a debugger and prevents the debugging activities from being successful as well. So combining all these layers of protection, your JavaScript code will be completely protected from attackers that want to tamper or mess with your code and can even warn you if they are doing so. But product features aside, we also made sure that this is easy to use. It's easy to integrate JScrambler into your build process, and we support all the major JavaScript frameworks and techs in the market, including native scripts. But that's enough information. Let's move to our actual demo. This is our native script demo app. We'll be using a to-do lists application, which is very simple. This version that you are seeing is currently in free user mode. And what we'll be doing is we'll create 2 more lists to reach the limit, and then we'll try to create 1 more to see what happens. It's also important to tell you that this is an offline application, so it must work without internet, which means that the checks must be done on the client side. Okay, and let's try to do the 4th one. And when we try to create it, it says that we are not allowed to. So we need to upgrade to the premium version to get the unlimited lists. But instead of paying, let's see if we can tamper with the app into thinking that we are a premium user. So our goal is to change the source code, and we'll start with the original APK file. So we need to decompress it and access the files. And now let's check the JavaScript's main file, the bundle.js. This is the file that contains most of the logic of the native script app. As an attacker, I'm looking for some way to change my user status from free to premium. And so I'm looking for some keywords like premium. And depending on how the code is structured, that can take more or less time to find it. But in this case, it's actually quite easy. I just found the isPremium function and changed the whole thing to always return true. So at this stage, the tampering is done, and all I need is to recreate the APK file and run it in the emulator. First, I need to uninstall the current app. The second step is we need to install the tampered APK. And finally run the tampered version of the application. So right off the bat you can see some differences. For instance, you can see the premium user on the top. But so far it looks good. but the ultimate test is just to see if we can create more than 3 lists. Okay, so we have been able to successfully create over 3 lists, so the attack was successful. Of course, it was successful because the attacker was able to fully read and modify the original JavaScript code. But what would happen if the code had been protected with JScrambler? So we'll show you the attack again against the code protected with JScrambler. But before that, let me show you how you can actually protect the code with JScrambler. So I'm entering the native script application folder. We will need a JScrambler configuration file, and we have one already in place. And we'll need a Webpack, a JScrambler Webpack plugin in order to integrate this into the build process. So we'll need to install this plugin, and we'll need to use the plugin in the Webpack configuration file. We only need 5 lines of code, and we already inserted them in the Webpack configuration file. Okay, so let's build our protected app. Our configuration file already includes the JScrambler advanced obfuscation and self-defending features. So we are good to go. So I'm skipping the build of the actual APK because that would take too much time. And I already have a pre-built APK with a protected version of the original source code. So I'll need to first uninstall the current application. And then proceed to install the pre-built APK. Let's wait a bit and launch the application. Okay. So as you can see, we have the free version of the app again. So let's proceed to unpack this APK and see if we can tamper with the code. Let's open the same file again. And as you can see, it looks completely different from the original source code. So if I try to search for the same functions like is premium, I won't be able to, because the names and even the structure of the file is completely modified. So as an attacker, I can try to look for things, for clues and things that I can interfere with to try to hack the code. I can assume that eval, I'm seeing some evals here that they are being used to decode encoded code. So my next step would be to replace an eval by a console log to try to see if we can grab the underlying code. Let's try to do that right now. Okay. And obviously I will need to repackage the application. And because we don't have time for that, I already have a pre-built version of this APK. So we'll need to uninstall the current version and to install the pre-built version of the protected sample that has been tampered. So as you can see, the app is opening, but it's already spilling a lot of different errors. And this is exactly the purpose of JScrambler self-defending features. So we were able to correctly identify that the code has been tampered, and this is the expected result. JScrambler actually scatters the integrity checks all over the application source code. So any change, even the slightest and smallest modification to the code will be detected with this runtime protection, and the code will break on purpose to prevent the attack from being successful. On top of this, our code transformation is polymorphic, which means that every release of your application will actually result in very differently looking codes. And this really makes it harder for the attacker to sustain any attack against the application code and make it more difficult to reverse the code of the application. So at the end of the day, the self-defending feature as a reactive protection measure can be used to prevent the tampering of the application, or at least to prevent the application that has been tampered from running. So as you saw, it's very easy to modify the JavaScript of a native script application. In the case of this attack, we unlocked premium features, which would hurt sales and ultimately the company, of course. But other attacks could steal your code, your IP, or could change the behavior of the application, or even steal sensitive data from the user. So JScrambler provides sophisticated JavaScript protection features, quite easy to integrate this into your native script build process. So basically there's no reasons why you shouldn't start protecting your code. That's it from my side. Thank you. And back to you, Rob.
Awesome. Thank you, Pedro. And remember, just head to jscrambler.com to start your free trial. You can also read a full JScrambler tutorial on the NativeScript blog at bit.ly/ns-jscrambler. Now, source code security doesn't end there. There's some other simple steps we can take to protect our app code. Are you a developer working on an internal, enterprise-y type of app? Maybe something that only needs to be deployed to a smaller set of users versus the entire world? A good option for you may be a private app store. Now, there are many options here for you to consider. The first and most powerful and the most complicated are the mobile app management and mobile device management solutions like Mobile Iron, AirWatch, or Zen Mobile, among others. Along with traditional device management capabilities, these solutions also provide app management and authorization of said apps by user. Otherwise, if you want to roll your own, you can look at the Apple Developer Enterprise Program. It does cost $299 per year instead of the traditional $99 per year that you normally pay to be part of their standard developer program. When you sign your app with an enterprise provisioning profile, you can then deploy it any way you like, even outside of the public app store. And Android, of course, allows for private distribution as well. In fact, you can set up your own app marketplace, use a managed version of Google Play, or send out apps via email, or even create a basic website that serves as an app store if you want. Now just know that if you don't use Google Play, you can't use their in-app billing services. Also, your app users do have to change a setting to opt in to allow installation of apps from unknown sources. So yeah, it's kind of tedious, but it definitely works. And remember, in the context of what we're talking about today, we are focusing on using private app stores to avoid having our apps fall in the hands of someone who, well, we may not want to have access to the app code. Now, the next step in securing our source code is to, well, remove that code entirely. So what I mean by this is taking potentially sensitive code and instead of executing it in the app, run it on the server. Now, this can have multiple benefits. First, you're protecting your intellectual property, as I've mentioned a few times already. Second, you don't have to worry about securing your source code, as that logic is invisible to the end user. And third, by using a robust backend, execution of said code could actually be faster. Now, an easy way to do this is to take advantage of the serverless function capabilities provided by Progress Kinvey. Now, Kinvey is a scalable backend that works with virtually every mobile platform via an array of fully featured SDKs. So you create low-code microservices that run on fully compliant and secure instances in the cloud. Now, Kinvey is laser-focused on security, with support for a variety of compliance considerations like SOC 2, HIPAA, GDPR, and Sarbanes-Oxley. Now, HIPAA is a big one here in the US. If you're developing anything related to healthcare, whether it's for providers, insurance companies, or patients, generally speaking, your app and backend have to be HIPAA compliant. Kinvey can handle that out of the box. And you can learn more at progress.com/Kinvey. So at this point, let me introduce TJ Van Tol. TJ is, again, our principal developer advocate for mobility here at Progress. And TJ is going to dive into the serverless and security capabilities of Kinvey. TJ, go right ahead.
Awesome. Thanks so much, Rob. My name is TJ Van Tol, and I work as a developer advocate at Progress here on the NativeScript team. I'm going to be doing a couple of demos for you today, and the first is going to be about securing your front-end code. Now, as you heard earlier in this webinar, front-end code, whether it's in a web app, a hybrid app, or a NativeScript app, is publicly accessible to really anyone. So you've heard about some solutions like Uglify or services like JScrambler, but for my demo, I want to talk about using a different approach, and that's using a serverless technique to protect your source code. If you're new to serverless, the idea is really pretty simple. Instead of hosting server-side code on your own infrastructure and your own servers, you instead host that server-side code on someone else's infrastructure or someone else's servers that live in the cloud. As a developer, this gives you a number of benefits, and I'll be talking about a few of these as we go throughout the demo. But since we're security focused today as part of this webinar, I'll be focusing on showing you how you can use a serverless approach to essentially hide bits of your client-side code that you don't want anybody else to get their hands on. Now, personally, I think this is easier to see in a demo, so I've got two different scenarios set up to show you today. For the first, we're going to pretend we're working on a weather application, and we're using a third-party service to retrieve the actual data that drives this app. Now, our security concern is that we want to avoid shipping the API key that we use to access that third-party service, as we don't want a malicious user just taking that API key and using it to rack up our bill. For the second scenario, we're going to work on a budgeting app for a large financial organization. The app has a sort of proprietary algorithm for scoring or grading the user's budget habits, and it's an algorithm that the company doesn't want to fall into the wrong hands. They don't want to make it publicly available, and therefore they want to hide this source code as well. Now, to solve these scenarios, you could use really any serverless provider, but just so that you can see a specific solution in action today, I'll be using Progress Kinvey, our serverless provider here at Progress. Now, Kinvey is a good choice because Kinvey integrates really well into NativeScript apps, but the tips and explanations I'll be giving today, I'm going to try to keep things pretty generic because really you can use these techniques with any serverless provider. So with that in mind, let's switch over to my development environment and see how this works. All right. What you're seeing here is NativeScript Playground, and I have the first of our scenarios, a weather app here, up and running on my device. For this app, I'm using OpenWeatherMap, which is an excellent little weather API that's really easy to use. But, as you might expect, OpenWeatherMap charges money at certain tiers. So our security concern for this app is exposing the API key that we use to actually access this service. And if I go into the app and scroll down here a little bit, you can see currently it lives right here in this function. So our task today is to take this API key and to move it out of our client-side code and into a serverless function. Now to do that, I'm going to start by bringing up the Kinvey console, which is essentially your dashboard for doing all things Kinvey. The easiest way to write a really simple serverless function using Kinvey is in the business logic section that you see over here. And what I'm going to do is start by setting up a custom HTTP endpoint. I'll add an endpoint. We'll call it weather wrapper, as we're wrapping the API key here. And then I'm going to choose to go straight to the editor. Look at some of these other options here momentarily. And I get a little code editor where I can write my function directly in my browser. And actually, since this is a pretty simple use case here, to return the API key, all I need is a single line of code that's going to add the key to my response body. And when I save here, I'm actually done already. To test this, all I have to do is send an HTTP post request to the correct endpoint. And Kinvey's got a little sort of console here to make testing that just a little bit easier. So I'm going to send a post, and I named my endpoint weather wrapper. And if I do that and go ahead and send, you can see I have my API key coming back from this already. This works, and what I could do is I could just head straight back to my app, and I could switch things over to use this endpoint that we just created here in Kinvey. Before I do that, though, I do want to make one more change. Now, if I switched over to this endpoint right now, back in my app, I'd actually have to chain multiple HTTP calls. That is, I'd have to perform a call to actually get this API key from my backend console, and then I'd have to turn around and make a second call to actually hit the OpenWeatherMap API and get the data that I need. I could do this, but in situations like this, I usually find it easier just to do the work in the serverless function itself, because you can actually do quite a bit. And to show that, I'll go back to my endpoints here. I'll find this weather wrapper, and I'm going to edit it. And what I'll do is just replace this with a little bit more comprehensive of a call here. And what I'm doing is I'm not only embedding my key here, but I'm actually making the HTTP call to hit the OpenWeatherMap API directly here in my serverless function. And if I save this and head back to my app, all I need to do to hit this new endpoint is, again, I could just manually make the HTTP post request as part of my NativeScript app here to hit this and swap that over. But in the case of Kinvey, I actually have a little convenient SDK that makes hitting this endpoint just a little bit easier. So in this case, it'll be kinvey.customEndpoint.execute, pass it the name of the endpoint itself. I'm passing the latitude and longitude. And if I save this and switch back over to my device, you'll see that the app continues to function exactly as is. The difference is, though, that my API key is now safely hidden behind a serverless function. Plus, I do get some sort of auxiliary benefits from taking this approach. The function that I have back in Kinvey in my serverless provider here is now something that I could call across multiple apps. Maybe I have multiple weather apps I'm developing. Maybe I have need for this code in my web apps and my mobile apps as well. And because this code lives in the cloud, I now also have the ability to tweak the functionality here. Maybe I need some slightly different weather data. I need to manipulate this data a little bit. I can do all of that here in the cloud and deploy changes to this function without having to redeploy all the apps that use this code. So there are some security benefits and also just some benefits to how you architect the apps that you need to build. To look at this a little deeper, let's look at one more example. Remember that the second app I want to show you is a budget scoring app. So I'm going to go ahead and open that app up and get a QR code so we can actually see what this app looks like on my device. There it goes, loading up over there. Now for this app, remember our task is to hide an algorithm that grades the user's budgeting habits. And you can see that grade popping up on this scale over here. Now that algorithm right now lives in an Angular service. I can bring it up over here, somewhere down at the bottom. Here we go. For today's purposes, I've obviously dumbed down this algorithm significantly. Hopefully you wouldn't use this logic in a real-world budgeting app. But there is a little bit more complexity here than in our previous sample, because this algorithm expects a list of transactions, or really just a non-trivial amount of data, as input. I include this because I not only want to show you how to move, say, a larger chunk of code to a serverless approach, but also to show you that you can do some pretty powerful stuff with this approach. In Kinvey specifically, although you can write quick serverless functions in the browser, like this, which works great for really simple things, you also have the ability to create essentially your own node modules and run them on Kinvey's cloud infrastructure. And in Kinvey, these modules are called Flex services. And before we started today, I wrote a quick Flex service for this budget score application, which I have up over here. Now, what I want you to focus on is not the specific code, although you can notice that the algorithm in question lives over here, but rather that you have a complete node environment here. I have the ability to break my service into multiple files. I can install dependencies from npm. You can see I'm using the same sort of package.json configuration here. With Kinvey specifically, I can tie into my application data. You can see I'm actually getting transactions from my backend collection. I can also integrate those collections with other data stores, whether they live someplace in SQL Server or Oracle or Salesforce or some other location that I'm storing enterprisey sort of data. Really, there's just a lot that you can do with this sort of approach. Now in Kinvey, the way you build and manage Flex services is through the Kinvey CLI. So when I'm ready, when I've developed this thing locally, when I've tested it out, I would use the Kinvey flex deploy command, which will actually deploy my service, if I can type it correctly, from my local environment where I'm building it up to the cloud where it's ready to actually run on Kinvey's infrastructure. Once that's done, the process I use to actually get my Flex service ready to use is pretty much the exact same as what we looked at with business logic earlier. I'm going to set up a new custom endpoint. I'll go here to add an endpoint. I will call it budget score for the budget score application. But this time, instead of developing my serverless function directly in the code editor, I'm instead going to choose this microservice option, which is going to give me the ability to tie into the budget score Flex service that I wrote. I'll write this for my development environment and the get budget score handler that I made a part of that method. And really, that's it. To use this new Flex service, which I exposed through this endpoint, all I've got to do is head back into my method here where I determine my score. And instead of doing things manually, instead I'm going to point things at the custom endpoint that I just created. And my app will refresh. And as you'll see, my app is going to continue to function exactly as it did. But now the code that drives this algorithm, instead of living in the app as part of this function, now lives in this Flex service node library that I developed locally and that runs on my serverless provider's cloud infrastructure. The big picture here is that, again, with the serverless approach, you're able to take sensitive code that lives on the client side and easily place it into a server-side environment. This is a great approach to take with really any code that you're worried about falling into the wrong hands. And you get some cool auxiliary benefits, like being able to reuse your functions across applications and being able to change your functions and services without having to redeploy all your apps. If you're interested in learning more about serverless and Kinvey specifically, head to bit.ly/kinvey-serverless. But as I said earlier, the same basic security technique works regardless of what provider you use. I've got one more demo coming up for you later in this webinar, but for now, I'm going to send things back over to Rob.
So TJ just provided a great solution for the all too common issue we see with mistakenly sharing private keys. This happens all the time on GitHub or Bitbucket or wherever we store our source code. Someone mistakenly includes something like this, either their Firebase or Azure keys or something like that, and then they're shocked when next month their bill goes up to $100,000 or something ridiculous. Now, I'm probably not telling you anything new, but when using Git-based source control, you should always use a git ignore file. This simply excludes files from being included in your repository. For instance, in my default git ignore, I use the following to hide app keys and Firebase configs. Pretty simple. Simple step that can really pay dividends. So now that we have some good ideas on how we can help secure our source code, let's next look at how data generated or downloaded by our app is secured. While out of the box, data saved by an app on both iOS and Android are effectively sandboxed, it's always a best practice to encrypt your data when it's saved. Now luckily there is a sweet little plugin called NativeScript Secure Storage that allows you to easily take advantage of Keychain on iOS and the Hawk library on Android to encrypt and securely store data. Now this shows off a huge advantage of NativeScript, and that is having 100% access to native device APIs out of the box. And this one set of code here, it works on both iOS and Android without needing to make any customizations per platform. Now that's a great solution for key value storage, but what about local databases? Well, many of us use SQLite as our on-device database of choice. And yes, of course, there is a NativeScript plugin called NativeScript SQLite that you can use. And using SQLite with NativeScript is really no different than using it with plain old JavaScript. The familiar select, insert, update, delete commands, they're all there for us who still prefer those relational databases. But I mention this because in addition, you can pay for a commercial version of that plugin to get access to SQL Cipher, which encrypts your SQLite database on the device. You can learn more and find this option on the author's website at nativescript.tools. Now, when you're using a remote backend for your app, a common consideration is online and offline sync of your data. You want your app to be fully functional in both connected and disconnected states, right? Now, once again, this is where Progress Kinvey shines. Kinvey provides online-offline data sync options that let you customize how you resolve these connection issues and how you manage potential data conflicts. I bring this up here because Kinvey also provides for encryption of the data on the device. And as I just mentioned, conflict resolution is baked in, as Kinve is flexible enough to allow you to determine how potential data sync conflicts are resolved. Now you can learn more about the technical implementation of this on the Kinve Dev Center at devcenter.kinve.com. And I can't not bring up again compliance considerations when it comes to choosing your backend. For customers in banking focused on FFIEC or GLBA regulations, in healthcare focused on HIPAA, or doing business in the EU and concerned about GDPR, really the Kinve platform provides comprehensive end-to-end security. Read more about it at progress.com/Kinve. Okay, let's shift gears again and talk about how we're going to now secure this data between our device and our remote system. How do we securely maintain data integrity between every device and our backend? Let's start with SSL, or TLS rather. Starting with iOS 9 and actually Android 9, any remote asset that you touch must be retrieved with TLS. Now I say must in quotes because it's not quite as cut and dry as that. App Transport Security, ATS, is a default feature of iOS that enforces increased security on external connections in terms of the TLS version and certificate signing and such. But you can turn this off by using the NSAllows arbitrary loads key in your info.plist file. But please don't do this. In fact, with apps submitted to the App Store, you actually have to justify why you need to allow for arbitrary loads of unsecured data. Likewise, as I mentioned, Android finally forces this on any app targeting the Android 9 SDK. Yes, you can get around it with some tweaks to your network config file, but again, don't please. The moral of the story here is, though, thankfully Apple and Google have wisened up and communications are now secure by default. But that isn't really where the story ends. It's a great start, but there is more. What we desperately want to avoid are man-in-the-middle attacks. A man-in-the-middle attack is a situation where someone secretly and transparently relays and possibly alters a communication between two parties who believe they are directly communicating with each other. Now, clearly, this is a huge issue when we are talking about ensuring the integrity of data in transit. And thankfully, there is a solution for us. It's a concept known as SSL pinning. SSL pinning is the act of verifying the server certificate against a known copy of that certificate. So it does this by bundling your server's SSL cert inside your application and making sure any request validates that the server cert exactly matches the cert stored with the app. Pretty simple, right? Now, of course, there is a NativeScript plugin to address just this scenario. The NativeScript HTTPS plugin is a drop-in replacement for the NativeScript HTTP module. You can read more about using this plugin at market.nativescript.org, but since it is literally a drop-in replacement, there are almost zero code changes you have to make, assuming you are already using the built-in HTTP module for your remote calls. I think this is a great time for me to introduce Alex Ziskind. Alex is Technical Director at Nuvius and the person behind much of the learning content you'll find at nativescripting.com. Alex wanted to introduce the new course that he has just made available, all about app security. Alex, take it away.
Thanks, Rob, and thanks for having me on here. It's a real honor. A little while ago, I ran a poll to see how devs perceive their mobile applications. Is it secure? Is it not secure? And I was shocked to find out that most developers either know their apps are not secure or they have no idea whether their apps are secure or not. So this really lit a torch for me to complete this course, which has been over a year in the making, so that we can start helping devs get a hold of their security matters and really get up to speed on how to get their mobile applications safe. Now, I have a bit of a network and application security background myself, so I thought this would be a perfect course, and putting it on native scripting would be a perfect place because we have this evolving ecosystem that keeps growing and the courses keep changing, and the security landscape keeps changing all the time, so we can keep adding and making this course more robust as time goes on. This course is called Securing NativeScript Applications. It's a 4-hour intermediate to advanced level course, so you should already know a little bit of NativeScript or be familiar with it. And this course gives you hands-on experience and tools that you can apply right away to make your NativeScript mobile apps more secure. There are really two parts to this course. The first part of the course focuses on client-server communication. So what's involved in HTTPS communication and how to use SSL pinning in a NativeScript application. How to generate, validate, and use JSON Web Tokens to protect custom APIs. How to use third-party identity providers with the OAuth 2 protocol. And in the second part of the course, we focus on the client, specifically data storage techniques and code protection. So how to store your secret information on the client, what storage mechanisms and tools to use and how they differ. We also examine hiding secrets using a serverless configurable cloud function in Azure. We compare and contrast local storage, session storage, application settings, and the native secure store capabilities that come on the device so that you can make the right decision for your business. And we also compare and contrast different tools to protect your JavaScript code itself. This course has some introduction in theory and briefly covering HTTPS pinning and OAuth 2 with the OpenID Connect protocols, but most of the course is just using a practical approach to getting security done. I hope that everyone watching this webinar gets a chance to grab this course with the special bonus code that we're going to give you, and I hope you get a lot of value from this course. All right, thanks. Back to you, Rob.
Great, thank you, Alex. Now, yes, I am happy to provide all webinar attendees with a 30% off code for Alex's course on nativescripting.com. Just use NSSecure when ordering this security course from NativeScripting. Now, the last piece of our puzzle today has to do with securely authenticating and authorizing your app users. So let's start with a secure mechanism for authenticating our users, and that is with biometric authentication. You know it as Touch ID, Face ID, or fingerprint recognition. The general idea is that we're using hardware on the device to securely authenticate device users. Now, the days of passwords and passcodes are gone, people, and thankfully these hardware capabilities exist on most devices these days, so it's time to modernize. So Touch ID for iOS and fingerprint recognition on Android, they're effectively the same thing. You likely use them every day. The basic concept is you authenticate users via their fingerprints, which are scanned before devices are unlocked. And Face ID, it's iOS only for now, although there are plenty of Android implementations either just here or coming soon. For some reason, this image from Apple is a bit disturbing on a kind of a Black Mirror level, but instead of Touch, Face ID scans your face to identify and authenticate via the forward-facing camera. Now, once again, there is a NativeScript plugin that allows us to easily tap into these capabilities, no pun intended. NativeScript Fingerprint Auth is the go-to plugin that handles Touch ID and Face ID for iOS and fingerprint recognition for Android. Now, it has the same cross-platform API. Now, with the fingerprint auth.verify fingerprint function provided in the plugin, you can be on your way to biometric authentication in no time. I should also this time mention a nice walkthrough of using this plugin with NativeScript and Kinvey for an end-to-end project. It's available at bit.ly/ns-biometric. So we feel pretty good about the mechanism with which we are identifying our users on the device. But what about the next step in tapping into existing authentication and authorization protocols? Well, the most popular of these is probably the OAuth 2.0 protocol. When you think of some of the popular auth providers like Microsoft, Facebook, and Google, you're also thinking about OAuth. So to leverage these auth mechanisms, you'll want to check out the NativeScript OAuth 2 plugin. This plugin helps to simplify access to these providers, but you can also roll your own if you really need to, or even use your organization's own provider. The plugin is pretty great. There are some demo apps that show off the implementation with Angular, Vue.js, or plain JavaScript. Now, to take this another step further, it should be no surprise that the NativeScript and Kinvey teams have made this process even easier. There is a free tool we offer called NativeScript Sidekick. This is a desktop app that provides a GUI on top of a lot of the NativeScript CLI commands. But it's also great for building apps in the cloud, allowing you to build iOS apps on Windows. However, I'm not here to talk about Sidekick, but I am here to talk a bit about the enterprise auth template within Sidekick. Now, this app template is designed to help you to connect to your enterprise authentication provider as quickly as possible. Think along the lines of SAML, OAuth, or OpenID providers. Now, powered by Kinvey, the enterprise auth template guides you through the process of connecting to your provider and makes it super easy to customize your login screen. You can find more information on using this template within the Sidekick client, which you can download for free at nativescript.org/sidekick. So at this time, I'd like to invite TJ back to the stage to give us some more insight on how we can easily take advantage of enterprise authentication capabilities in our apps.
All right, thanks, Rob. This is TJ again, and I'm back for one more demo, this time on enterprise auth in NativeScript Sidekick. And I'm actually going to hop right over to my development environment so that we can dive right in. What you're seeing here is NativeScript Sidekick, which, if you haven't used it before, is our desktop development tool for NativeScript, and it runs on macOS, Windows, and Linux. I'm going to start by creating a new app using this button here. And as you can see, in Sidekick, you get this nice graphical UI that walks you through the app creation process, where you can choose between frameworks and also different application templates as well. This is a demo on enterprise auth, so let's go with the enterprise auth template here. We'll give this new app a name and go ahead and create this new app. This process will take a few seconds to complete as it's scaffolding out a new application for us. And when it finishes, you'll see this screen, which is the main dashboard for your new app. You can see that Sidekick detects any devices that you have connected. These can be simulators or emulators or physical devices that you have connected to your machine through USB. In my case, I have a single iOS simulator running, which we'll see here in a moment. You can deploy these apps to any devices you see listed here. And it's worth noting that Sidekick also gives you the ability to build your applications in the cloud, which can be really useful if you're developing on Windows and Linux and you want the ability to build iOS applications. Now, before I started this demo, I actually went ahead and deployed an app using this template to my iOS simulator, just so you can see what this template looks like. But the app won't work quite yet, because I haven't told Sidekick how to actually perform the connection to my enterprise auth provider. And you can see that Sidekick's already prompting me to do that. On this screen, you'll see that you have to fill out a few values about your provider. And honestly, this is really the only hard part of the process. Under the hood, the actual authentication is powered by Kinvey. And as such, you can connect to any provider that supports either SAML, OpenID, or OAuth. And most providers support one, if not all of these protocols. The hard part is getting the values you need here, because they're dependent on your setup. And there's a pretty good chance that you'll have to work with someone in your organization to find the correct values that you'll need. Here, I'm inputting the values for an Active Directory setup that we have running on Azure. On the NativeScript Sidekick documentation, which you can find by clicking this help link over here in the top right corner of the screen, you'll find guides that will help point you in the right direction for gathering these values, including a full walkthrough of connecting to an Active Directory instance. The good news is, though, that once you have these values, you're essentially done. All you have to do is save these values, head back to your devices list, and go ahead and run your app. The process will take a minute or so, as Sidekick is performing an actual full iOS or Android application build. Mine is going to go a little bit faster because I performed a build of this same app earlier. When it's done, you'll see it's starting back up here. You'll be able to test things out on your device. You'll see that when I hit this login button, I now go directly to my auth provider for authentication, which in my case, again, is an Active Directory instance running on Azure. If I log in with my credentials and manage to spell them correctly, there we go, I can now focus on building the rest of my application. The great thing about using the NativeScript auth template from a security perspective is that you don't have to reinvent the wheel. That is, you can reuse the existing authentication system that you already have at your company or organization, but integrate it into a modern mobile app with NativeScript. To get started building this functionality into your own apps, you can start by downloading NativeScript Sidekick at nativescript.org/sidekick. And you can also check out Sidekick's enterprise auth documentation at bit.ly/sidekick-enterprise-auth. Finally, if you're looking to see this topic covered in more detail, Alex Ziskin, whom you heard from earlier, has an excellent premium video course specifically on NativeScript Enterprise Auth, and you can find that listed as a course on nativescripting.com. Hopefully you'll give Enterprise Auth a shot in your own apps. It really is a great way to build some pretty awesome functionality just on top of your existing infrastructure. And with that, thanks for joining me again, and I'll send things back to Rob one last time.
Awesome. Thanks again, TJ. Okay, we've covered numerous topics here today, some of them probably too quickly, and I thank you all for staying with us. Hopefully you've learned just a thing or two about app security. But to wrap things up, we covered 4 high-level areas of security: securing our source code to protect intellectual property, mitigate any potential threats to our app or backend systems, and hide any private keys. We also talked about securely encrypting data at rest on the device. We moved from there into protecting the integrity of our data as it travels back and forth between the device and our backend server. And finally offered a few little tips on improving user authentication and authorization with existing hardware and existing services. If you haven't already, I wanted to remind you to check out nativescriptdevday.org to get all the information you need on the next NativeScript conference, this time held in Amsterdam. Sounds like a good excuse to me to spend a few days with the Dutch. Now, where do we go from here? Well, of course, I have some next steps for you. You're not going to find a more secure or compliant serverless platform than Progress Kinvey. Sign up for your free trial at progress.com/Kinvey. Get 30% off the Native Scripting Security course with the NS Secure code at nativescripting.com. New to NativeScript? Look no further than our docs and the NativeScript Playground as a great first step. Start your journey at nativescript.org. And again, be sure to visit nativescriptdevday.org to learn all about our upcoming NativeScript conference in Amsterdam. As a reminder, early bird ticket sales do end at the end of January. Finally, thanks again to the JScrambler folks for joining us. Curious about JScrambler? Well, grab your free trial at jscrambler.com. Now, thank you all very much for attending. We will be here for a while yet to answer your questions in the Q&A panel. So if your question hasn't been answered yet, just hold tight. All right, for the rest of you, have a great rest of your day.